We are a second-generation family-owned business, 47 years. We're located in Jersey City, New Jersey. We have 150 employees working for us. My relationship with Matt Testa and Bijou Properties started when we had the opportunity to bid on the 1415 project.
We have been working with Sal Electric for the last 4 years on a handful of projects. The most important was Park and Garden.
The main building that we did was 1415 Park, and we did the entire electrical package. So there had to be the highest level of coordination amongst everybody. It starts in the beginning with bidding a project. Schneider Electric helps us by positioning Sal Electric into a position of being competitive. Schneider Electric's engineering department, along with my engineering department, spent a tremendous amount of time reviewing the drawings, reviewing the documents. Their engineering department provided us with a tremendous amount of support. We were able to get equipment to our job sites in an expeditious fashion. I could give my order to anybody, but it's what company is going to stand there with me when there's a problem.
Sal Electric, they were able to work with Schneider Electric to choose the best products that would fit both the budget and the quality they were looking for. It's been seamless.
The quality of the products coming to the site, the personnel, it's been a good experience right across the board. As an owner of a company, if I have that comfort level and I see that there's a company like Schneider Electric with the Square D product making my job easier, that's what differentiates certain companies with others.
Hello everybody, my name is Phil Santoro and I'm the Electrical Contractor Segment Manager for Square D. I'd like to thank you for attending today's live broadcast event. Today we are here to review some of the code changes for the 2017 National Electric Code. We have an opportunity for us to get an in-depth review about the most pertinent changes to the code, along with how the code revisions will benefit you and the opportunities they bring, major provisions that will require you to change your standard practices, and how these codes will impact the way you bid and install your projects. But before we begin, I want to cover a few housekeeping items. Take a look at the bottom of your audience console. You'll see a number of icons, or widgets as we call them. If you have any questions, click the purple Q&A widget at the bottom and type in your question. We will have a Q&A segment at the end, but feel free to type in your questions anytime. You can even tweet us at @SchneiderNA and use the hashtag #CodeChangeIsComing. If we don't have time at the end of the session to answer all of your questions, we will answer them directly afterwards. Now I would like to introduce you Amr Paul, our Senior Vice President of Operations here at Schneider Electric. Amr?
Great, thank you, Phil. We really appreciate the opportunity to talk to you and your team here. I'm joined by my colleague, Chuck Buckley. Chuck, why don't you introduce yourself?
Sure, yeah. So I'm new to the role. I'm in running the national sales force, as you know, for the U.S. It's essentially the sellers and the project management team managing our electrical distribution and industrial automation solutions in the U.S. Came from the IT business, as you know, was there for 22 years. That was all about critical infrastructure for data centers and computing environments, but spent the last 6 months on the road, meeting with customers, meeting with partners to understand the business. And one thing that really strikes me is the heritage and the brand quality of Square D. And my whole mission and my team's mission is to make sure we continue that forward.
That's great. And you know, Chuck, as he joins us as the leader of national sales, led the same mission for APC, which is another storied brand in the Schneider portfolio. And I think this is the value of Schneider, is not only do you get great brands like Square D and APC doing what they do, but you as a customer have the opportunity to bring them together to create best-in-class solutions for your customers. And we see that in data center, we see that in water, healthcare, and a number of different end market segments. But today we're going to talk about the contractor market specifically. And as I travel, one of the trends I see is a lot of discussion about labor. And that's really broken up into two parts. One is just finding the right number of people in a market. But the second part is training. You know, as our technology gets more and more complicated, there's a lot more metering, there's a lot more measurement, there's a lot more connectivity. IoT is the buzzword, but basically we're trying to make these breakers set up in a way that the operational efficiency is a lot greater. So how do you train people on that? And whether it's codes changes, which I know Phil and team are going to talk more about, how do you get the right information out? So that's one big pain point. Yeah. The other one I hear is just faster. Everything faster. Speed. Compressed timelines, you know, much more revisions on drawings, drawings coming in less complete. Yep. And BIM, as a part of that whole process, as a digital way to accelerate all of that, is becoming more important. Everyone wants more 3D models, more BIM integration. Yep. And then the last piece that I hear about is just the tolerance for post-order conversion execution, right? Where is my order? The project management.
Transparency. The
transparency. I need to know where things are because everything's moving so quickly that I can't, you know, the latency there, even before we get to the job site, is really, really key. So absolutely. As you travel, you've been getting to meet our customers. You know, does that resonate? What are you hearing?
Absolutely. I'm hearing the exact same things from the field. A lot about absolutely getting in earlier in the process, which again is a good thing in many ways if you can influence that sale. But as you said, oftentimes the drawings are coming in 25% complete. So now we've got to respond much quicker. We have to do many more revisions. It takes more work. So ways of streamlining that process and getting more transparency to the tools and the information that our people need, our partners need, is of utmost importance. So we got to continue to push that adoption and push the awareness out there.
I think, you know, like any digital tool, one of the asks we have for our partners and customers is the only way we get better is by you using them and giving us feedback, right? No digital tool is ever created perfect. But with your involvement and the direct relationship you had with Square D, we are the company we are because we've worked with customers like you. And every time, whether it's the removal of a pigtail on a QO breaker that allows us to plug it in, therefore save a lot of time in terms of efficiency, or the metering management in our meter solutions, making them plug and play, the simplicity of our new drives and all of our process. All of those things are really built on feedback we get from our contractor partners.
Premset, safety, premset, medium voltage, having, you know, solid insulation materials to not have you know, energized parts, you know, in the way of our people, so they can stay safe. Low cost, low weight, you know, to help maximize that electrical distribution space. So yeah, we're taking this input and we're trying to really drive innovations out into the marketplace to help add value to our customers, but also help our contractors with the installation and bringing them into the market.
One of the things I'm excited about is Order Tracker. So in the next few weeks now, we're going to launch a tool at My Schneider where you can see the status of your ETO order in real time. Right. That's pretty exciting and first for the industry.
And then order status is going to come on top of that. So we're going to keep revising and improving our solutions. So Order Tracker is allowing you to get that information, the base information, and understand when it may ship. Order status, you can start to, you know, hover over certain elements and understand, you know, where it actually might be milestones in the manufacturing process, right? And if it's shipped, you know, where it is along the shipping logistics path. So we're going to continue to revamp and revise and improve these to give that transparency that our customers and our contractors demand in this fast-paced market.
And you know, the most important asset we have in all of this is not only the feedback we get from you, but we have really the best distribution network in the industry. We're incredibly proud of our premier partners, and they bring a lot of that knowledge and integration, and our job is to always work with them so that collectively as the manufacturer and the distributor, we can deliver an experience to you that is really world-class. You know, as we wrap up here, you know, the team is going to talk about some of the code changes on NEC and FBA. One of the things that's really important is to make sure that for all the technology, all the connectivity, all the digital tools, the foundation of our industry starts with safety. And I know the Square D company has built its reputation, Schneider Electric, on safety. One of the things we always invest in is training of our services teams on how to work safe with what is dangerous equipment. What are you hearing in terms of the needs of contractors on that front?
Yeah, it's of utmost importance always. Anytime your employee is your most important asset, and safety is the most important thing that we should be driving out in the marketplace. So not only do we need to build it into our products and services, make it easier, and make the awareness out there and training, and it's a complete ecosystem that we've got to be driving, but it is the number one priority for our contractors and for our people as well, our own service people.
I think in everything we do, we believe in quality, and while there's a premium to pay, we believe that quality ultimately pays for itself, whether that's a safety conversation or it's how we design equipment or how we build it and how we deliver it. Well, look, we really appreciate you joining us. I hope you'll enjoy the session with Phil and team. This code update is critical as part of that whole narrative, but also takes some time to introduce these new tools, and we'll have more information later on in this webcast about how you can get access to and try them, and we love your feedback. So if there's anything we can do better, let us know. Thanks, Phil.
Thank you.
Thank you, Amr and Chuck, for sharing. Safety and standards are of the utmost importance within Schneider Electric and one of our core values. The 2017 National Electric Code comes with significant changes, and I want to address the importance of these changes to help you understand how these impact your projects and business. I want to introduce to you today the panel of industry leaders who are involved with the National Electric Code. On my immediate left is Alan Manchi, Schneider Electric's Vice President of External Affairs. He serves on a number of NFPA technical committees, including Code Panels 2 and 10 and the National Electric Code Correlating Committee. Next, I'd like to introduce Chad Kennedy. Chad is the manager of industry standards for power equipment and a member of the NFPA, serving on several committees with the National Electric Code and NFPA, including Code Panel 13. Last but not least, we have a special guest with us today, Mike Johnston. Mike is NECA's Executive Director for Safety and Standards. Mike is also the chairman of the National Electric Code Correlating Committee and an alternate on Code Panel 1. He has also served on National Electric Code Panel 5 in previous cycles. Welcome, gentlemen. I appreciate your time attending today.
Thank you. Great to be here.
So the 2017 National Electric Code has introduced many changes from the 2014 version. While there are dozens of critical changes to the National Electric Code, we only have a short period of time to cover the ones we think that are most critical to you. We're going to focus on just a handful of these changes today. Some of the topics we're going to cover today are arc fault energy reduction, GFCI protection, and receptacle requirements in the meeting rooms, just to name a few. I want to point out additions to the code, new National Electric Code articles in 2017. We won't cover these in detail today, but you should be aware of these additions and trends in our industry. These articles are 425, fixed resistance and electrode industrial process heating equipment, Article 691, large-scale photovoltaic electric power production facility, Article 706, energy storage systems, Article 710, standalone systems, Article 712, direct current microgrids. Mike, as Correlating Committee Chair, can you give us a little bit of color on why these additions were added?
Sure, Phil, thanks. I'd be happy to. These new articles actually resulted from about 2 cycles of development work by the technical committees. And it all started back where there was a focus, an increased focus on energy reduction and wise use of energy. And that resulted in the 2014 edition of the code with an article dealing with energy management systems. And there was about 2 cycles worth of work from about the 2011 NEC up till the 2017, where we see in the Chapter 7 of the NEC articles dealing with energy storage, articles dealing with microgrids, and articles dealing with standalone systems. And it's all about being able to manage the loads efficiently on a site. It's about resiliency, and we're going to see a lot more opportunities for our contractors in these areas. So the NEC is equipped nicely moving forward to be able to have rules to apply to these installations and systems.
Great, thank you, Mike. So it's time to kick off with the first section. Chad, can you tell me more about section 110.16b about arc flash hazard markings?
Thanks, Phil. We start right out of the gate with one of the most important and significant changes in the 2017 National Electrical Code. Non-dwelling or non-residential service installations at 1,200 amperes or more will have a new arc flash hazard marking. This marking will require that you include the nominal system voltage, the actual available fault current or three-phase voltage short circuit current, the clearing time of the overcurrent device, and the date that the marking was applied on the service equipment. There's also an exception to this section that allows you to omit this marking if you performed an arc flash hazard analysis in accordance with NFPA 70E, and that's evidenced by marking on the equipment. Now, this is a site-specific marking, so it depends upon the site-specific installation criteria and the overcurrent protected devices used. We have an example label here that would show you with the highlighted portions what the minimum requirements from this new change to the 2017 NEC. Now, moving forward, there are a lot of changes in the NEC, and this is yet another marking requirement for the electrical contractor. So my colleagues, perhaps you want to weigh in on how this marking differs from what is already required, specifically what's required in 11024 for the maximum available fault current.
And I mean, absolutely, right? The electrical contractor here is going to be challenged with regard to making sure they get actual information here, right? From a serving utility, typically we're looking for the maximum numbers, right? To size equipment, look for that available fault current, that maximum available fault current. In this case, we need to know exactly what the number is so that we can look at the opening time, we can understand the information to apply the appropriate PPE. So we're talking about the safety of people and ensuring that we get the right numbers. So the contractor, the utility, there's going to have to be some communication here, or the engineer on the project, right? Since we're talking about 1200 amps and above, maybe some engineers involved at getting that information that ultimately gets put on plans for the electrical contractor to utilize.
That's an excellent point, Alan. You make a good point about differentiating the marking requirements in 11024 from 11016, and one needs to be a lot more dialed in to make sure that the incident energy and the level of PPE required to be worn for protection is accurate, whereas over in 11024 you're dealing with values, maximum values that relate to equipment ratings and suitability for use on a system within its capability. So it's an expansion of the markings in 11016, but if you look close at that section, you'll see that the additional criteria on that label is installation related, which differentiates itself from the criteria that you see for labels in NFPA 70E, and that had to be the case because of the differing scopes between the two documents.
Thank you both. From a safety perspective, before we leave this topic, it's important to recognize that although this label is on the service equipment and it includes the clearing time, the available short circuit current, this should not be used as the available incident energy or arc flash hazard determination for the service equipment. This marking is used for downstream equipment from the service equipment. Most electrical equipment has not been evaluated for how an internal arcing event happens within the gear and what happens to the exhaust gas and how that arc moves around in the equipment. Arcing events can result in moving from load side to line side, therefore really invalidating using of the clearing time to determine your hazard level. So this marking provides beneficial information where you're looking at equipment that's downstream of the service equipment and how that overcurrent protected device will clear and provide you some level of protection there. But within the service equipment, again, it doesn't use the correct values for the service equipment because most equipment can have faults move from the load side to the line side. Now, staying in 110, we look at new requirements in the 2017 NEC for reconditioned equipment.
Yeah, thanks, Chad. 11021A, list item 1 and 2, provide the information related to what a manufacturer has to provide on equipment in terms of marking. And also in list item 2, we now have addressed within this section requirements for refurbished, reconditioned, or remanufactured equipment. This is not something new that's going on in the industry. This has been going on for a long time. The NEC is actually incorporating rules that now address requirements or provide requirements for equipment that is refurbished, remanufactured, or reconditioned. And the specific criteria is that the organization responsible for the remanufacturing of the equipment and the date of the reconditioning of the equipment have to be provided on the label. And this is important for not only installing contractors to make sure that the responsibility lies with the organization responsible for it, but it's also an important feature for inspectors as they carry out the significant responsibility for approvals.
Right, absolutely.
Thank you, Mike. Thank you, Mike. So for the next question, Alan, can you give us more around the inspections and tests around section 110, 110?
41. Okay, yes, 11041. So 11041 is a new section in the code that is specifically trying to package all of the testing and information that's necessary in the over 1,000 volt arena, right? So it's not a new language, right? We're pulling from 22556, where we had we have feeders where we have to set the parameters of the overcurrent devices, the relays, and all that information has to be available for the contractor, for the inspector, for the facilities engineer beyond commissioning of that information. And so this information has now been, the general area that has now been moved to 11041, so that we're making sure we're having that information available to everyone on the site to inspect, to install, and looking across other areas that are over 1,000 volts. I mean, you may look to areas like services that have over 1,000 volt requirements. You may look to selective coordination, right, in particular articles that are where we have over 1,000 volt needs. And that information now needs to be available for the installer, the inspector, to make sure the settings are all in place. And so I think this is a good communications aspect that we've added to the code.
Great points, Alan. I think that, once again, this is not something that's new, introducing something new to the industry. This is ongoing. Typically with medium and high voltage systems, equipment, and applications, you usually have these performance tests and verification that systems are going to operate as intended when they're energized. What this does for the inspection community as well, it gives them another basis for approvals by the requirement for having these tests documented, these performance criteria documented in a way that they can use that in addition to their inspection while they're looking at energizing or approvals to energize this equipment.
Thanks, Mike. Appreciate it. Chad, can you give us some information on the changes on 210.8?
Yeah, glad to do so, Phil. 210.8 gives GFCI protection for other than dwelling unit locations. And we have an expansion here for single-phase receptacles moving from 20 amperes to 30 amperes to 50 amperes, and three-phase receptacles moving to 100 amperes. In our list of items that require GFCI protection, we also expanded to include unfinished basement areas and crawl space areas. Now, we've had the requirement for non-dwelling or commercial kitchens. This also incorporates other wet location areas, such as where you may have food preparation with stainless steel countertops, electronic appliances, refrigeration, and yet you have the same washdown type requirements you might have in a commercial kitchen. So the GFCI protection is required. It gives you have the same level of hazard that you would have in a commercial kitchen. So the code is aligning with this to provide that protection in those areas.
Absolutely. And Code Panel 2, right, that has jurisdiction over this and discusses all of the proposals that come in around this space and where do we enhance protection necessary. Often the GFCI protection area comes with an electrocution, unfortunately, right? We don't like to see those, but typically when those come in, the technical committee is very adamant about acting. And so when we saw the addition to the crawl space, that was an electrocution. Somebody was under there and got their hands into a light fixture because of that confined space area. So some action was taken to address that. We see, to your point, Chad, I know we were talking about, think about kitchens, right? The commercial kitchens, when we added GFCI to the commercial kitchens on the 120 volt, right, it was a gentleman that was mopping and backed into a live casing on a commercial refrigerator freezer unit that electrocuted him, unfortunately. But we acted to address that in the commercial kitchen, and so this takes on a little further role, thinking that we have commercial mixers, right, at 240 volts. We have other types of equipment that have the same hazard, and we're able to address that here and make sure that we don't have those incidents happen.
Great. Thanks, Alan. So our next section, I'm going to ask Mike, Section 210 around Section 210.11 around garage branch circuits. Mike, can you shed some light on that?
Yeah, thanks, Phil. Panel 2 acted favorably to strengthening the requirements for branch circuits that supply dwelling garages, and it relates to more power capacity primarily. In this section, the code used to allow a general purpose 15 ampere 125 volt branch circuit to supply not only the garage, but it could extend beyond that and supply other areas of the home, and got a little more restrictive this cycle in that now the receptacle outlets in the garage are required to be supplied with a 125 volt 20 ampere branch circuit. It relates to larger loads that might be used in those locations, like larger tools and so forth, so capacity is increased. And this works very well for occupants. It addresses nuisance tripping issues and so forth. There is an exception that will allow an extension of that branch circuit to the outside for an outdoor receptacle on the outside of the garage as well. And also this aligns nicely with the recent additions in the code to require a receptacle in each bay of the garage so you don't get into cord abuse issues out in those locations.
Great. So for the next one, Alan, I'm going to pick on you. We're going to talk about 210.12 AFCI interruption protection.
All right, absolutely. So 210.12, we saw some expansion in AFCIs around dormitories and around hotels. All right, so in the dormitories aren't like what we went to college in, right, or where we spent our time. They're completely different. We're starting to see more of an apartment look, actually. So we've actually seen expansion in AFCIs into bathrooms in those dormitory areas, as well as devices. So devices now picking up things that control lights. So if I have a balcony now off of my dorm and have a light switch that controls something outside, I would need to provide AFCI protection with that light switch that's controlled inside for that particular area. I also have the hotels. So we have covered hotel suites in the past, but now what we've done is expanded to all of the rooms. So beyond hotel suites, we are now covering the hotel rooms with regard to AFCI protection and picking up a requirement there to provide further protection. All right, so moving into a few other areas that can see the same type of arcing hazard.
Great. Thank you, Alan. So this is an interesting topic. Mike, on Section 210.71, meeting room receptacle outlets. Can you shed some light on that?
Very good, sure, Phil. It's nice to see Code Panel 2 act favorably to include these new requirements for meeting rooms. When we talk about and consider abuse of cords and the way portable power taps have been used in meeting spaces, this change seems long overdue, in my opinion. So we ended up with a 210.71, and it's kind of a layout, if you will. This is its first hit to the NEC. But what it does is it addresses those meeting rooms up to 1,000 square feet. So anything bigger than that, exhibition halls and so forth, you're not going to apply these rules to those facilities. Well, what this is all about is coming up with a criteria, which Panel 2 did, and providing it in a code rule to determine the number of receptacle outlets that are necessary for a meeting room, and also giving you specific requirement for placement with regard to the floor receptacles if you need those in those spaces. So essentially what we end up with in 210.71 B1 and 2 is the requirement for establishing the number of receptacle outlets in those areas, which when you go back to what's required for a dwelling unit in 210.52A1 through 4, that's essentially what you're using. So you'd use your spacing requirements, 6 foot from a door and 12 feet there between. You would use that, and that would determine the quantity based on the room size. And once you got the quantity, the code allows a design criteria to come into play. In other words, the owner, the design team, and so forth can specify where that quantity that's established could be placed. So here you've got a prescriptive requirement that also includes some design criteria and allowances to address some performance needs. As far as the floor receptacles, the floor receptacle requirement applies where you have a meeting room that's over 12 feet in width, and you end up with a square footage of somewhere around 215 square feet. When you have that amount of an area, you have to add an additional floor receptacle. It's also anticipated that you may deal with portable or movable partitions that may divide the space, so the floor receptacles come in handy to be able to not leave a space without a receptacle if the partitions are in place. So I would encourage the users of the code to visit this. It probably will evolve further, but I believe Panel 2 hit the nail on the head with addressing a need in the industry and providing a means moving forward to refine it even further so we address those spaces and the power in those spaces.
Absolutely.
Good. So Chad, next one is section 220.12, the exceptions around the lighting loads and for specified occupancies.
Great, thanks, Phil. So Article 220 covers your load calculations for your buildings. And we had an exception in the 2014 NEC that really dealt with an adopted energy code where you could use the exception there to use power monitoring with alarms. And it allowed you to lower your energy load calculations for lighting loads. Now a new exception's added in the 2017 that goes a step further. If you have it calculated based on a lighting density, you can there reduce by 1 VA per square foot for banks, office buildings, and facilities like that. So we're seeing another area where the code is taking into account your energy efficiency gains by following your adopted energy codes. And I think this makes sense going forward as the buildings will have less infrastructure, but they have a less load as well.
Great. Chad, also, can you talk more about performance testing in section 230.95?
Okay, so 230.95, we're talking about ground fault protection at the service. So where ground fault protection at the service, 230.95 sets those requirements, and it requires that you test the ground fault protection system for the equipment after it's installed at the site. Now this change adds a new paren C, which is very significant to the electrical contractor because it sets the method of testing as primary current injection only. Now this is going to be impact to the contractor and the manufacturers of equipment equally. For simple systems, say a single main with feeders and branch circuits, the manufacturer would often include an integral way of testing the ground fault protection equipment. Could be a push-to-test function, could be a handheld test kit that could be used with the circuit breaker or a protection relay. Now we're forced to primary current injection. So the impact to the contractor is this is special equipment, and it's probably going to require logistically that the contractor manage the site. If you've already made line-side connections, they have to be disconnected in order to provide this test. So let's take, for example, a 3,000 amp circuit breaker. You would very easily have 9 conductors per phase, and if you've already landed those conductors, they would have to be removed, restrained for this testing to be applied, and then reconnected. If it's supplied by busway, you might have to move sections of busway. If it's a unit substation application, you might have flex connectors from the transformer to the equipment that has to be removed. So logistically, this really has to be managed. The test equipment is fairly expensive, and so the contractor may want to consider third parties or other people that can help there.
So I mean, really we're looking at, right, bolt the equipment down, mount the equipment, and do the test, right, before we pull those conductors in, before we make the attachments so that we don't have to undo things and put it back to make it efficient for the contractor, I think. Would that be accurate?
Yeah, that's great coverage of the change, Chad. This is way more than a push-button test, folks. You're dealing with actual injection testing on site, and it gets real interesting. As Chad said, when the equipment's first installed on site, this has to be performance tested. And recall that in healthcare facilities and other types of systems and installations, you can have multiple levels of GFP installed. And when you go into those sections of the code, they typically point back to 23095 regarding the performance testing. So this not only happens at the service level of the installation, but it could happen wherever you have a GFP installed on the downstream side.
Excellent topic, excellent topic. So Alan, we'll move on to the next topic, arc energy reduction in section 240.
All right, 24087. We have a list of items in 24087 that continues to support safety with the electrical contractor and reducing the arc energy of the system, right? For 1200 amps and above. So I mean, one of the things here is continuing to recognize technology that can do that function, and so we've added a couple of items to the list, and those items are really already built-in functions to the overcurrent device. In most cases, you have an instantaneous setting on the breaker. You could have an instantaneous override, and we're now permitted to use those. We'd used them as an equivalent means before, but this really recognizes being able to use those as long as we demonstrate that they are still going to pick up the available arcing current, right? So we have to do a little bit more work for these two to understand what that arcing current, that available arcing current is going to be, right? Which I'm going to give you a rule of thumb. You have to do the calculation, right? But half of the available fault current, right? But it's going to be something less, and we have to make sure that instantaneous setting is going to pick up that current. We don't want them to be ships missing in the night or passing in the night, right? So this provides us with the capability, if you do a little homework, you may not have to have some additional equipment to do it. So you have to invest up front, right, to do some calculations, to do some evaluation to see if you can actually use these two, all right?
Great, thank you, Alan. So Mike, the next question I have for you is, what are the changes, or how are they impacting the changes in single-phase dwelling feeders in Article or Section 310?
Yeah, thank you, Phil. That's a good change for industry. It actually takes Section 310.15b7 and expands it to 208Y120 systems from the 120/240 volt system. So that's the big thing that you'll notice in 310.15b7. This is the section of the code that actually acts as an exception to Table 310.15b16, your normal ampacity values. You're allowed to take a 0.83% reduction factor from the values in Table 310.15b16 and apply those to services and main power feeders for dwellings at the 100 amp level through 400 amp level single phase. So the big change in this section allows one to take a single phase feeder from a 208Y120 fed service and supply the main power feeders or the service itself. So an expansion within that section.
Good, good. So Chad, I'm going to pick on you next. Power monitoring equipment in Section 312.8.
Right, so power monitoring equipment. A lot of customers are asking for a way to measure power within the electrical equipment. And we've had this really undefined requirements in the National Electrical Code on how do you do that, where can it be located. And we've had instances where authorities having jurisdiction or the electrical inspector is not comfortable with this equipment, such as current transformers and other devices associated with the power monitoring or metering being located in the wiring space. So this change is really a great benefit to that. It clarifies how this can be done, what type of listings are required to be included, and the fact that it addresses the wire fill issue. Does it take up too much of the wire area? So it falls into the same cross-sectional area that you would have for splices, taps, and other items that end up being permitted in that wiring space. So this aligns with, we covered the 2012 exceptions for when you add power monitoring based on the adopted energy code and any other reason why you might add power monitoring to an equipment such as a panel board.
Great, thank you, Chad. So Alan, next topic, Section 408, service panel boards.
Okay, so this is the barrier for the incidental contact. So in 408.3, what we've done is we've actually added language, added panel boards to what's already in place with regard to incidental contact for switchboards and switch gear. So this adds it to this adds protection, shock protection on the line side of the overcurrent device. Most people probably will relate this to residential panels probably most often, I guess, because you may have seen, for those across the northern tier of the country, would see the steel barriers from Canada, and it provides some great protection from a shock hazard. The difference, though, right, is that in Canada, those panel boards are often mounted sideways, with the wires going out the sides of the panel instead of the top. So the U.S. manufacturers come up with some innovations here to take care of, to particularly take care of that incidental contact with barriers that would still allow the conductors to go out the top and down out the bottom of the panel. So you will see various applications for that, but a little bit different than what maybe folks were thinking of, at least that were familiar with the Canadian barrier. This is giving that incidental contact aspect from a shock hazard on the top of the panel. Keep in mind, this is not protecting from an arc flash event at all. So once again, it's simply an incidental electrical shock contact type of protection, and we still have to take into consideration the other hazards around working electrical equipment in accordance with 70E.
And Alan, one point also is that many manufacturers will also include these as a retrofit kit. So if you have a panel in the field and you would like to add this protection, most manufacturers will have a means for you to do that.
Absolutely. Great protection.
Great, excellent. So Mike, another important topic is grounding and bonding in section 449.
Yeah, thank you, Phil. Panel 11 acted favorably to a proposal to require an equipment grounding conductor in outdoor portions of metallic raceways that are installed in rooftop locations where they supply combination load and multi-load equipment. And it relates, their substantiation was there relating to equipment and the conduit specifically being vulnerable to physical damage based on location and service operations and so forth that may happen on rooftops. So the result is that a wire type equipment grounding conductor be installed in those metallic raceway systems, and it only applies to the outdoor portions of the raceway system that are on the rooftop. And of course the wire type equipment grounding conductor would be sized based on table 250-122 at a minimum in those locations.
Great. So it's pretty clear that the National Electrical Code for 2017 is full of safety enhancements for the public and electrical worker. We encourage you to review these changes and learn more about other additions to the code. It can help you, your employees, and customer to enhance safety and adaptability. Square D by Schneider Electric will continue to support the electrical industry with our proven performance products, innovative solutions to help you increase your profitability and access to information to help you drive your competitive efficiency. If you haven't done so already, don't forget to register on our contractor portal where you can download an Arc Flash code guide, read the latest National Electric Code revisions, as well as watch this broadcast on demand. The link to this portal is located within the resource widgets at the bottom of your screen. Now let's answer some of the questions that have come to us from the audience. As a reminder, if you have a question, click on the purple Q&A widget at the bottom and type in your question. You can also tweet us at SchneiderNA and use the hashtag #CodeIsChanging. So we've had some questions already come in from the audience, so I'm just going to throw them out there and you guys go ahead and pick at them. Yeah. So the first one that has come in is in section 239.5, there's a question: can breakers be removed from the gear and tested with current injection and bolt back into the gear?
And the answer to that is no. The ground fault protection equipment will include neutral sensors that are not associated with the breaker. So you think of a breaker that is 3-phase, 4-wire application typically. The neutral sensor is part of that ground fault protection equipment, and so all of that busing system needs to be in place. And if you go through the testing that the manufacturers provide you, there's both load and no load testing and line and low side testing for that ground fault protection of equipment. So the bottom line is you'll need to follow the manufacturer's instructions, but it will be with the breakers installed in the equipment.
Great, thank you, Chad. Let's see the next one. Why are the meeting receptacle outlets required within 6 feet of the wall rooms wider than 12? Shouldn't it be no less than 6 feet? Otherwise, I could put one 6 inches from the wall, and that provides no advantage over a wall outlet. So can I repeat that?
That's a good question, Phil. I covered that change, so I'll respond. The 6 foot measurement, I think, primarily comes with the standard length of equipment that would be supplied with a cord. The cord is typically, by the product standard, a length of 6 feet. And you get further away from the wall than 6 feet, you start looking for use of extension cords if there's no receptacle available. So that's really what's driving that 6 foot measurement that you see from the wall, in addition to the receptacles that would be required for the wall space in that section.
Okay.
I think we're going to see, right, I think the code panel did a great job of getting this underway, as you pointed out, Mike. I think, questions like this and enhancements, right, to be able to get it completely right, or if there's things that need to be tweaked a little bit. Mm-hmm. And this is a great opportunity for folks to think about the language here a little bit and submit a proposal that we can act on, right? I mean, believe it or not, that comes pretty quick. I mean, we're talking like September of next year, so we're less than a year away before we work on the 2020 NEC, and comments like this are very valuable as we talk about, making sure we get things tweaked just right that helps the contractor.
And that's a great point. This is the industry's code. I mean, everyone can submit a code proposal. I mean, and that's some of the best code proposals come from the inspectors and the installers out there, because they're usually the closest to identifying the gaps and the needs. So great point. Yeah, and the first run, I think Panel 2 did a great job on this. It's great in its first version, but I'm sure that there will be some tweaking going along, and it'll just be better as we go.
Mm-hmm. Great. Next question. Does 408.3 A, to make the panel a non-live work situation if the main breaker is off and I have an arc flash protection on?
So the requirement in 408.3 does provide electrical shock protection. So there were areas in the country where particularly the utilities really frowned on pulling the utility service meter away. So yes, if you do have the main breaker off, you wouldn't be exposed in a single main breaker application. You wouldn't be exposed to line-side bus. And that's really the intention here. It is an electrical shock protection. If something were to fall, or there's something wrong with that equipment and you were to create an arc flash event, well then the equipment has not been evaluated for that. But it is going to provide an electric shock protection so that all your line side, so that you can turn the main breaker off, suit up for arc flash protection, and verify and then work on the load side of that main breaker.
Great. These are excellent questions. Keep bringing them in. We have one for section 110.16b in reference to fault current on the new label. Is the current a maximum available fault current or a real available fault current number?
So this is the real available fault current number. This is the huge challenge. So it's not the number the utility gives you. It's not the assuming an infinite bus and using the transformer. This is really calculating based on an accurate number from the utility through the transformer and what you have based on your conductor length. What is the real available fault current? That is the challenge here. Wouldn't you guys agree?
Absolutely.
And the important thing to remember with this new requirement and the new criteria on the label is it lines up nicely with use of the table method of establishing incident energy levels and level of PPE to be worn. And what we mean by that is you're using a clearing time and you're using an available fault current. And the combination of the two, when you look at the table method in NFPA 70E, that's how you arrive at those values for your protection. The difference is with regard to the rules in 70E related to the labels, those are dealing more directly with incident energy levels and level of PPE. The scopes in Panel 1 was very, very careful to not step over its bounds with regard to what it included on that arc flash warning label, and kept it installation related criteria, which is important. And NFPA 70 needs to complement NFPA 70E where everybody wins.
Absolutely.
Here's a kind of a general question, but it's around primary injection. Can testing ground fault and trip with primary injection be done at the factory to the entire assembly?
So when we have a complicated equipment lineup where we have multiple sources, then certainly that testing is done at the factory to assume that all the ground fault system and parameters work as designed. But the NEC is very clear that the final test is done at the installation. So it has to be done on site.
Okay, great, thank you. Another question, any discussions about adding safety in indoor parking lot poles by requiring a means of disconnect at each pole for safety maintenance personnel? Example is a large parking lot such as the mall.
There wouldn't be a requirement, but it wouldn't preclude a designer from specifying a disconnecting means for service purposes. When you actually get into the luminaire itself and you look in 410, there were requirements for disconnecting means introduced recently at ballasted, but those were applicable for double-ended lamp-type luminaires. Okay. But nothing specific unless it's a part of a specification from a designer at this point.
Okay. This is a topic that I'm pretty close with around training. Due to the changes to the NEC regarding performance testing, will there be training available to contractors on testing equipment and purchase of the equipment? So where can they get this training currently?
I mean, I'll take a shot at it, but I think what's going to unfold, right, is probably you're going to get information, first of all, from you have manufacturer's instructions, right, that come with the equipment on and how to do it with regard to what the exercise is to walk through it. Now, that doesn't mean that a contractor would have all the equipment to be able to do that. So I would anticipate that a lot of third-party activity would initiate here, or potentially, right, a services organization, such as what we provide from Schneider in the services side could provide that. But I would suggest that as the knowledge base of that information is better understood, and if you're a contractor that has a business that sees a lot of those installations that would validate the need to invest in the equipment to get that done, then sure, absolutely. I mean, I would anticipate there being training and implementation of that activity around that space.
I think NEDA has information and standards about the testing that actually complements the manufacturer's requirements regarding testing. That can also be a resource, and I know they have there's multiple organizations that can provide that testing, and I know a lot of contractors are certified to provide NEDA testing on site.
Great. Got another 11016B question. I see that arc flash hazard marking in 11016B includes the date the marking was applied. What is the significance of including the date, and does it mean marking is required to be updated on some interval?
So I'll take that one. The date is to give you an idea of when the available fault current and associated clearing time were determined. Changes do happen to these systems. The utilities change the available fault current or what's available, and those type of changes to your power system need to be incorporated and those numbers reevaluated. Mm-hmm. So the date, there's not a hard requirement out there that says every 5 years you have to go re-verify this information, but it will provide you indication of the age of the information and when perhaps things have changed, that it needs to be reevaluated.
Mm-hmm. Okay, great. Another question, when is selective coordination required, and is there a marking requirement for it?
That's a pretty broad, I guess I've got to say that's a pretty broad discussion, right? I mean, from healthcare to emergency systems to from a code requirement perspective, right? I mean, so we've got, elevator, there's a whole list of those in the code where there's a selectivity requirement in place today. As far as a marking requirement, there's not a marking requirement. I think the new 11041 probably provides a mechanism for that information to be communicated so that right? The people know where the settings go. They can be verified by the installer or addressed by the installer, verified by the enforcer or the inspector, and provide that communication piece. So I think that, I don't think there's no specific marking requirement, but it does, there's various areas, and I mean, we'd get into a pretty extensive discussion here if we jumped into each one, but which I don't think we necessarily have time for at this point. But
a good place to start with a question like that is to refer the user to the definition of coordination, selective, and what that means. Really, it's about localizing an offending ground fault event to the lowest point on the system so you don't end up with a blackout condition in your facility. The locations and systems you see it installed in are essential to life safety within the facility. Often when you're building a system and designing it such where it's a defend in place philosophy used, critical operations power systems often include them in IT applications and other facilities where loss of power due to a complete blackout of the facility would introduce increased or additional hazards, not only within that facility, but it could be beyond that facility. So that gives you an idea of some locations in the code within the NEC where selective coordination would be required and why.
Mm-hmm. Thank you, both of you. Again, around the meeting rooms and receptacles, most rooms have often have movable partitions. Do I close all the partitions and consider each partition area a separate meeting room for this requirement?
I'll take a stab at that again. If you're dealing with movable partitions, you obviously want to put the partitions in place to create the smallest room. And that's the idea behind the placement of the floor receptacles if necessary. You set up with your largest room and you put your receptacles in based on the designer or owner's specifications after the movable partitions are in place. But the whole idea, because there's a design feature within that requirement, is to not leave one of those segmented rooms without a receptacle in that space.
Okay, great.
So it offers some flexibility. Prescriptive in the number or quantity you have to provide, but also gives you flexibility in design to make sure you achieve the objective.
Okay, great. I got a question on the garage circuits and receptacles. Is bay, considering a bay, one vehicle or one door? In other words, is a double door one bay or two?
Off the cuff, I would say if it's a double door and there's a space for two vehicles, it's two bays.
I'd agree.
Okay. Good, great. Next question is, does the requirements for a wire-type equipment grounding conductor in a rooftop raceway apply to EMT or all-metal conduits?
That's a good question. I believe the phrase used within the section is metal raceway systems, which would include EMT, rigid metal conduit, intermediate metal conduit, and so forth. And the idea here is if you're using anything other than threaded type fitting, slip fittings, in other words, compression fittings, and so forth, those are more likely and more vulnerable to movement and physical damage that could interrupt an effective ground fault current path. So the answer is it applies to all of those, but it's directly related to the type of fitting that's used in those applications.
Okay, great. Let's see here, we got more coming in. As they come in, let's take a look here. In regards to the new arc flash hazard marking, do I need to place this marking on all panel boards being installed on a project?
So the new change in 11016 really applies to the service equipment.
Right.
Mm-hmm. So it's a good idea, right, to know your arc flash hazard at all your panels.
Okay, great. Let's take a look. I'm waiting for the system to update. What is new happening in the field to drive the requirements, and why is it important to the contractors and inspectors? Kind of a general question, right?
For what topic?
It just says, let's see, what is happening in the field to drive the requirements and why is this important to the contractors and inspectors? That's all I have on that question there.
Well, the code is dynamic. It's a living document, and it's basically responsive to substantive changes that are proposed, changes that are backed up with substantiations, usually statistical information that is either in the form of injuries or deaths. And a lot of the code rules that you see today were written in blood, but a lot of the code rules that you see today are proactive work by the technical committees to anticipate the needs in those areas, so the NEC is equipped now and in the future with rules that can be applied to installations and systems as we evolve. But it's a dynamic document, and it responds to not only substantiated proposed changes that are backed up by statistics, but also anticipated needs and foresight by the technical committees in a more proactive and progressive approach. The committees have their work cut out for them. They're actually looking ahead, and they're also responding reactively to substantiation.
Great. I think we have time for one more question, and this is there's a lot to learn. Where is the best place to get more information on the NEC and the code changes? We'd go to the NEC National Electrical website.
So I mean, there'll be a lot of resources, right? I mean, look, we have a website, right, that has under support. There's a link in there for codes and standards under the support function for the contractors to come to Schneider Electric. NFPA has some great information. NECA has information. I mean, many of the associations and the trade associations across the entire industry are educating, right? Doing things like this in order to educate. So I think that you've got code changes from various organizations that publish books, online material. So there's a lot of great resources from various organizations, including ours, that can help support the education of folks.
Sure. Talking about online stuff, is there also apps available on this too? I would assume apps available for it. Okay, great, excellent. Well, I want to thank everybody for submitting all their questions. I appreciate everybody's attendance today. Continue to send in your questions, and don't forget to check our website, and as you can watch this video on demand. So thank you for everybody for attending today, and thank you, Alan, Chad, and Mike for being here today to do this.
Happy to be
Appreciate
here.
it.